Good afternoon. Good afternoon, ladies. Just so that I know whether I'm going to be repeating myself to you too frequently, how many of you were at the RISC Southwest show? Could you put your arms up? So 4, 5. Right. The London show last year. Same subjects, but obviously a number that haven't been to a show since last year then, or maybe even longer. Anyway, right, good to see you, thank you. Now, starting small. We'll start small. Most of you, I'm sure, have seen and know what this is now. This is a Pi Zero, the latest version of the Raspberry Pi, and this is actually in one of the cases that we're selling, holds £6 for the case. Pi Zero, yes, is in rather short supply and can't be bought from your usual outlets at the moment, unfortunately. We could, well, yes, ultimately we probably will sell some, but it's difficult to make a profit margin. It will, of course, run RISC just like your other Raspberry Pi. There are one or two slight differences, and people have found that you do need to use a pretty late version of one of the builds to get around a couple of silly little niggling problems. It will, of course, though, work with one of our real-time clocks that is quite interesting. Yes, the design that we did for when the first Raspberry Pi came out has worked without any changes whatsoever on every version of the Raspberry Pi that has appeared. Well, it's the Raspberry Pi Compute Development System, actually, because it didn't have I2C pinouts in the same position, but that's, apart from that, that would have just required flying it. But, you know, we have the, I know a lot of people went and picked up Pi Zeros, but if you want a little case for it, we've got those in stock. Then a couple of other odd things that I'll mention. Most of you here will have 2, 3, 4, 5. Someone in the room, I think he said 27 was the last mention I heard him say. Well, I've got computers. Most of them RISC computers. So one of the problems is having them all connected up and usable. Now that DVR, digital output, is quite common on your later stuff, but people often still need to be able to view via old analog RISC-PC or Ionics output as well. It's getting a proper DVI or HDMI KVM can be difficult, but we have managed to find these which are for a 4-port KVM. I think they are £99, but for a 4-port one, it is really quite good value for money. We believe, but we have some of those with us. The silly thing was that at the moment I can't find a 2-port. At a lower price than the 4-port, which just seems silly, but that's just the way things are on those. The Panda board system, now, some people might think, oh, well, that's sort of now old hat and dead, but as one gentleman this morning has already pointed out, he said he wanted something small, but he didn't want something that seemed quite as well. The later RISC-PC, so the later Raspberry Pis, with most of the cables coming out at one end, can be relatively neat, but they're still not massively neat. And in actual fact, was the cabling, because it's compared with the actual Raspberry Pi, the plugs tend to be rather large. But he was actually looked at the Baby Panda, because we still have some of these available, and the Baby Panda, so you have the SD card with RISC in it, up to 64 gigabytes, and you have your speakers, power in, network, two USB, and well, one of the HDMI monitors outputs here. And so if you're wanting a compact little unit, that is still available and a good option, I believe. Before I forgot to mention that Pi Zero does use some, because it uses a micro USB for data and a mini HDMI for the monitor output. But some of those cables are not so readily available, but we have a wide range of cables going to almost all options that you might need. We're either just converting, say like the connectors to a standard size socket, or to go to DVI socket or a full size HDMI, or a variety of those. One thing that, well, there are lots of actual people to thank in many ways, because RISC, there's so much of RISC, as many of you know, certainly on the software side of things, is done by volunteers, and I must say that we are very grateful to them for doing that. One thing that recently we're grateful for is Chris Johnson. He's been doing quite a bit of work with his program called CPU Clock. Now, CPU Clock, it initially, one of the things it does, it reports what the speed of your processor is, because a number from the Panda board onwards, most of the systems, including the latest Raspberry Pi, the iGet board, the base system, the Titanium base system, Panda board system, they have dynamic clocking. So basically, when they detect that they're not doing anything much, they slow down and say, well, I'm still here when you want me. Oh, you want me to do something? Right, okay, I'll run a bit faster. So that's it. One aspect of it is it just lets you know what it's running at now. That actually is of fairly academic interest. But one of the things that is more important is on some of the later systems, sometimes they can get a little bit warm. And so what has now been built into CPU Clock is a facility whereby you can say, if the core temperature inside the chip, and that now is available on a number of the boards, not all of them yet, but he's getting there, gets to more than a certain temperature, slow down until it drops by 5 degrees, which protects your system. Having said that, things like the iGet based system, its manufacturer statement was sustained use at 90 degrees C and higher will reduce your life expectancy. Now, not your life expectancy, no, its life expectancy. And when it gets 110, it automatically resets. But so the key thing was, we did realise there was a circumstance where, if on booting it was getting itself into something that was running very hard, you could then sort of have a vicious cycle. It would just keep getting higher and resetting higher and resetting. But basically, Chris Johnson up in Edinburgh has now done some really sterling work on that. Initially it was written as a little application, which was written in BASIC, but of course that means that if you've got a program that's not cooperatively multitasking, then it's not going to know that the temperature's gone up, because it's not going to be told about it, because this other program's gone off maybe and crashed, but in a loop that's pushing the temperature up. So he has rewritten it as a module, so it sits on one of the timers every 100th of a second or something, looks to see the temperature and monitors that. So that's a very useful and grateful thing that we are for him. So basically, we now come down to the the main thing. The two new computers. Now, the IGEP based, so we do two systems: the Rapido IG, IGEP V5 based, and the Rapido TI, which is the titanium motherboard based system. Now they both have a lot of similarities, and they also have a number of differences. And which is the most appropriate for you will depend on your particular requirement. But I'm going to go through the basics of both of them. Now, the titanium, which actually I've got one of them here. The titanium actually uses what they call a mini GTX motherboard size, and uses a standard PCIO shield. This is what that's referred to as, to give you your two RS-232s, two networking, two DVIs, and 6 USB. Now I've got these cables sticking out the back here because this particular unit we've added an internal card reader, and that wires into the USB via those. But on this one, it does, the other thing with the titanium is it has two PCI slots. We're utilising one of those for the cable at the moment. Now, I suspect no one ever may use under RISC the PCI slots at the moment. Yes, to prove it all works, LSR have set up a parallel port one, and it will work with RISC, but no one really needs that nowadays. Well, if they do need parallel port, a USB to parallel adapter will do the job. But it's a nice little case, integral power supply, and then on the front, two USB. The audio actually isn't brought to the front because that is on the back. And then there is a flap-down door, which either could theoretically have a 5¼ inch optical drive, or, well, whatever type of drive you wanted there. But what we normally do is we put in a slimline optical drive, and then in the space underneath it is normally where we put the SSD drive. We're only normally supplying these with SSD drives because now that the price of those has dropped such, it really seems silly to use anything other than them. But on this one, we've actually got the card reader, which is actually went for this particular card reader unit because it has a dedicated micro SD slot with Raspberry Pi and other things like that. Nowadays, using micro SD, we thought it would be, rather than have to fiddle around with adapters, having a reader that will just allow you to plug straight in would be rather useful. And it does have a USB port on the front, that's why there's two of those. Also, there's not a lot of space there, you see, but that's actually a 3.5 inch bay, suitable for a 3.5 inch, another 3.5 inch drive, or a 2.5 inch in a suitable adapter. And then on the outside of it, there is mounting for a 2.5 inch, another 2.5 inch drive. Now, with the SSD drives being really slimline, even though it actually is physically slightly above the motherboard, even if you put a PCI card in there, it's all you'd have a very unusual PCI card to actually foul that. And as I say, I don't think very many people will use PCI cards in there. So if you don't have a card reader, you could have 4 drives in there. You could have no optical drive and 3 SSD drives if you really wanted to. But I don't think many people will go for that option. It is actually still screwed together, otherwise I could show it to you, but if anyone wants to have a look inside, we can show you that easy enough. So that's basically more showing you the case, because the other thing is when we said someone was asking about buying one of the IGEP-based systems, we said, well, we could put it in one. He was talking about having an extra drive, so I said, well, we could put it in one of these cases. And he said, oh, I rather like that case, so he's actually bought his iGET in one of these cases. It, apart from having a different I/O shield and slightly different input outputs, which I'll go into in a minute, it's effectively the same. So, similarities between the two Rapidos. Well, one of the things is they both use a dual-core 1.5 gigahertz Cortex A15. So, those things that are purely in the ARM processor are basically identical in speed and usage. They are the same. But they are both. The main chips in the two of them, the AM5278 and the OMAP5432, they're both made by Texas Instruments. But as far as I can make out, they effectively have two different design teams, and they were doing slightly different things, but both of the two design teams ended up basically at the same place. In that a lot of similarities between the two, their graphics output for a single monitor, they both are limited. The graphics system basically allows for resolutions of 2048 by 2048. Not that I've seen any monitors like that, but with a limited bandwidth, which basically means that we've found out that you can get and also finding monitors that would accept the input. 2048 by 1440, we found some Dell monitors. They're natively 2048 by 1152, but they will actually accept the higher vertical resolution. They just squash it a bit. If you're doing CAD type drawings, I'm sure you wouldn't want to use that with very oval circles, but if you're doing it with text editing, it looks quite readable. Or some people say, well, that's a little bit too squashed for me, but 2048 by 1280 seemed quite reasonable and also worked. So that side of things is that the fundamental is very similar, but surprisingly, the actual fact speed of some graphics things varies quite a bit between the two. In actual fact, if you want, there's someone who's done benchmarks of a whole load of different aspects of both machines, and in actual fact also the ARM X6, the Ionics, and every other RISC computer that almost can be done on the Raspberry Pi. But those are, you can view all of the results at the website that we mention on the front of the green leaflet. And I've also actually printed them out, and they're stuck on the wall just down the corridor here on the right, showing all the benchmark. It's available there, and I'm thankful to Chris Hall for doing that. It's useful to have independent comparisons for that. So we noticed that something like, I think it's draw plotting was actually for some reason quite different between the titanium and the iGET being a bit faster. But if you look down the list, there are pros and cons. Some it's a bit faster on one, some it's a bit faster on the other. Both of them are nearly always quite a bit faster than the IMX6 based systems. In particular, you've got things like the SATA speed. IMX6 based systems, yes, it's quoted as being 2,000. On the IMX6 is quoted as being 2,667% faster than RISC-PC, so massively faster. The Rapido TI being 5,983, so more than twice the speed, and the iGET being 7,000% faster, so significantly faster than that. Now, sometimes the difference could be the particular drive being used, because they weren't always the same drive. In actual fact, when we tried the drive that was 7,000% faster on the iGEP, when we tried it in the titanium, it was about 5,000% faster. So we were getting on the same drive about a 40% increase. Now, whether or not using the drive that gave 5,900% in the iGEP, whether or not we would get 8,000, I don't know, but there seems to be some improvement there. So that is one of the things that there is a difference between the two of speed there. One of the other things is the titanium has on board what they call a SATA port multiplier, because both of them coming out of the main system on the chip is one SATA port, and then you can use what they call a port multiplier that does what it says. It doesn't. It's interestingly, I had wondered whether or not having a port multiplier would slow things down. It might, presumably, once it works out where the data needs to go, there will be a slight overhead for that, but I'm sure it is infinitesimal compared with the rest of it. But certainly when we did some tests, because we found that whilst the titanium has the port multiplier on board, the iGET doesn't have one, but we found a little port multiplier standalone unit, and we plugged that into the iGET-based system, and the benchmarks we got with and without it, connecting directly or via the port multiplier, there was no difference in the benchmark timings at all. So there is a slight difference there. Now, when in the standard cases, the port multiplier really wouldn't be because we normally put the iGET in a mini IGX case, but which doesn't have room for multiple drives. But concentrating back again on sort of the titanium, going down what it does. So the titanium, it has 2 gigabytes of memory, which is a lot, and not many people are going to run out of. I'll come back to that in a minute. The operating system is stored on flash memory. It doesn't need to be stored on, to initially boot, you don't need to have an SD card to do that. There is actually an SD card slot there, but it's inside on the board. But you don't need to use that, and that can be done. But the particular selling point of the titanium is the fact it has the dual output. You saw the 2 DVI sockets on the back. Basically, so you could have one monitor connected to one, another monitor connected to the other, and both monitors could be up to, we've had them both running at 2048 by 1440. So you have 4096 by 1440, and that will work. Whether everyone has the desk space to have 4096, and whether or not your head, you'll get a strain crick in your neck from moving it from side to side, I don't know. Now, I think the thing is, most people I gather, if they do have 2 outputs, they end up putting, relatively static displays or something they want to refer to every so often on one, and they're working on the other. It's a nice little arrangement. So that is the sort of of the differences. That, I think, is the main reason why some people will say the titanium, this one basic system, is the one for them. It does have 2 serial ports, but how many people use any serial ports nowadays? But yeah, some people may have a use for that. There are also actually on the titanium 2 Ethernet ports. RISC again can only really access one, and there are only some fairly special, normally business-orientated applications for things that have 2 network ports, as I understand it, but that I don't think is going to be applicable to the average RISC user. But if that's your requirement, then it's there for you. The titanium has 2 front USB and 6 USB at the back, so you're fairly well covered for your USB. You should rarely need to have external hubs for that. It does the the titanium does have a reset button, and this particular case does have a reset button on it. In actual fact, there's quite a few cases nowadays, unfortunately, that don't have reset buttons on them. But that is optional. And basically, one of the other problems is with the titanium is that some people, well, the cheap option of it, in actual fact, would be to put it in just a bog standard ATX case, because they are available really quite cheaply. Excuse me. One of the big problems with that is the fact that most PC power supplies nowadays, you know, you want a PC power supply, oh, do you want 500 watts, 600 watts, 700 watts, you know, and most of those, the minimum power drain will not be enough from these later systems to actually reckon it's got anything connected to it. But this one, it uses 160 watt power supply, and, you know, even without any extra drives connected, it is always started up for us, so we're confident in that being not a problem for people on that. So yes, what we're doing is with the titanium-based system, we're bundling in a 240 gigabyte SSD, so quite a nice high-spec SSD drive that, you know, well, in actual fact, is the problem with these later SATA SSD drives is they can be so quick that I don't think it's done what I've asked it to do. If you drag and drop something, say from a RAM disk, or to or from a RAM disk, you do not often, you know, even if you're saying copying 10, 20 megabytes, you don't actually get the box coming up saying, oh, I'm copying this, because it just does it. And I've more than one occasion I thought, oh, I thought I'd done, oh, I have done, but you know, I don't get the feedback telling me, because I've got to learn now that it's so quick. The other thing is, yes, Amulor, we haven't been able to test it extensively, but Amulor will work on the titanium. You do have to be using a non-ZPP build. The ZPP builds do not work with Amulor because the way Amulor has to do things and have what they call low vectors is an issue there. But ZPP is basically a very useful thing for debugging purposes, and is going to be present in beta builds, normal beta builds, but we're making available both ZPP and non-ZPP. So people, if they want to, if they're a programmer and want to sort of track down bugs in their software, then they can use one. If they're a user and they just want everything just to work, carry on working as it was, including some old software, then the non-ZPP is the appropriate one for them. It is actually just a matter to change ROM images. You know, it is just a matter of, well, basically dragging one file into a particular directory and shut down and rebooting it, and you know it's the RISC ROM image has to get into a particular well, that's true on the Raspberry Pi and the iGet thing. On the titanium, it actually you have a flash program. Sorry, I was getting myself confused there. A little bit like on the Ionics, that you actually program it into the flash with a particular program. At the moment, it's just a little one-line command program. I can't think of something like PG flash space -file space, well, RISC-OS. If you've given your ROM image the name RISC-OS and it's in your current directory, that's all you need to do. And it says erasing, programming, verify there, and it takes about 30 seconds to do that. Right. So the options on the titanium that we offer basically are the card reader, the extra SSD drives, and the technical reference manual. There's not really much else that one could offer on that. So now I'll move on to the iGet-based Rapido, the Rapido IG. Sorry, excuse me, I'm just going to take my jumper off, I think. Now, the IGET-based Rapido is, sorry, I forgot to mention, yes, going back to the titanium. Basically, as is, we're saying 999, but we are including that's including VAT, a price match promise that for similar specification we will match similar pricing, because yes, there are other people out there offering options there, but we offer to match those. But so the IGET based Rapido, basically, well, one of the things is, yes, it's £720, so you're looking at £279 cheaper. It doesn't have the second monitor output, and as standard, it doesn't have 5 SATA ports, but there are a number of other advantages to it, and I'll mention those now. Normally because it's a slightly smaller board, we are able to put it into a mini ITX case. That gives us a slightly smaller case, and we've actually got an option of 3 different mini ITX cases, 2 of which has a DC input from the outside, 1 of which has a mains input. Some people, by having the DC input, one of them is a 12 volt, so the option of possibility of running that off a battery would be a lot easier if it starts off with being 12 volt. But depends on what people like in the way of case. In actual fact, all 4 cases that we offer, the 3 mini ITX ones and the DTX, can be used in both tower mode. There's a sort of feet positioning for it in tower mode, or there's feet options there for it in desktop mode. And all the mini ITXs, I believe, they come with stands to allow you to, well, in actual fact, most of them, you just turn them on their side and use them, but some of them actually have proper stands to hold them in their tower mode. So they really are very small on the amount of desk space that they use. But when they are on the desk, most of them you can put on, a monitor. I suppose you can put an old massive CRT monitor on it, but the most LCDs can be sat on top of them. So the IGET based system, so yes, uses exactly the same processor as the titanium, and basically the graphics, for a single monitor of 2048 by 1440 is the same, although, as I say, there are some things that, like the plotting of draw plotting, for some reason, is quite a bit faster than on the titanium. The difference is, in actual fact, where there's a significant difference between the 2 systems, and this may also be true on other systems, well, the one that's being slow, I think there's a definite possibility that there may be some customization of RISC-OS that would improve the situation. So I think there is going to be, over the next few years, a number of improvements in RISC-OS, in the speeds, especially where people spot, well, this isn't as slow as it is slow. Let's see, why is it slow on this particular system? Oh, it's slow because of X. And it's from looking at, I regularly look at the rule list of changes that have been submitted into the sources, and it is quite interesting that people find that, oh, we made this change, and oh, we found out that it affects X, Y, and Z as well, and oh, they've become faster or more reliable and don't fall over when X happens. And it's very good to see that. Now, there is one thing that is actual fact I am hoping will happen, because whilst both systems have gigabit networking. The iGet-based system actually is via on-chip USB, so it can never be flat-out gigabit, but none of them, including going back to the Ionics, anywhere near. Well, we had the speed of the networking on the RISC-PC, and then they had like the Net 100 cards, which theoretically would have been 10 times faster, but in practice were about 2 to 3 times faster. And then we had the Ionics, which is 1,000 base, so you should think should be 10 times faster again, but again, I think was something like a couple of times faster. So most of that, the reason why is not the speed improvement there, I'm told is basically due to the software networking stack in RISC-OS, and that is an area that hopefully sometime will get addressed, and I think it will be interesting to find out what the network speeds then do achieve. But RISC-OS, the one great advantage for RISC-OS is the fact that, of course, that we very rarely are dealing with large data files or large programs. There are some, obviously, some exceptions to the rule, but generally speaking, we don't do massive amounts of that. But so the amount of time that you use your drive is not normally vast in the day. So for a single monitor, the iGet offers the same graphics output, and basically I've got a dual system monitors connected up to the Titanium, and just after this I'll be demonstrating the two working alongside each other, and can also demonstrate the iGet with its display. On the iGet we are bundling in 120 gigabyte SSD, and we can then upgrade that to 240 for only £35, so really relatively nominal amount if you're wanting the extra capacity. One of the improvements, like in actual fact, it only appeared in the last in the sources about 10 days ago, but is already on the systems that we've got for sale today, is that on board the iGet, previously we're booting from SD card, but there is some flash on board, and it basically, yes, it is seen as another SDIO device, just effectively like the SD card, and support for that was added in, and we are now storing RISC-OS on the on-chip flash. So there is a micro SD card there, but it's really just for backup purposes. So it's not necessary. And the flash chip appears on the icon bar as a hard drive, because it's non-removable, SDFS device. But generally speaking, we don't expect people to use that. So in actual fact, with a one-liner BAE file, you can actually remove the two of them off your icon bar. If it's RM kill SDFS file that just removes them from the icon bar and removes a bit of clutter, so you know you're back to your hard drive and your apps folder without any others. One unfortunate side effect of that was just around the same time was added into the sources some extra fixes to do with error trapping, which unfortunately then realised a few days later had a knock-on side effect of stopped CDFS from working. A fix for that is now in the sources, but unfortunately not in the ROM that we've currently got, but we'll have that next week. So things are moving really quite quickly, are on improving it and getting it there, but I am now using the iGet based system as my main machine for everything that everything I don't need to use my RISC-PC for. Fortunately, the one thing I still use my RISC-PC for is my email, because I'm using a server, the ANT server suite, because that allows us to do what they call concurrent multi-user email, which we can't otherwise do on that. But yeah, so it enables me to log in as sales at CJE Micros or Chris or support or 4D, and I can log out and my colleague and Andrew can log in as one of the others. And that's right, we now have, we've actually, because we are doing more stuff, we have actually now taken on an apprentice who is working with us. He's normally comes from the PC world land, so a little bit different to when he sees what we're doing. But yes, we're training up as much as we can to help us do all these nice things. So carrying on, move off from my side. So yes, so basically with the iGet-based system, so we've actually got the choices of 3 cases, 3 mini-ITX cases, or the DGX case, and we do also though offer the, if people just say, I just want the bare board with the operating system, but with SATA, because on the iGet, I meant to bring it in with me, but I can show you on the stand if you're interested. The drive actually fits, that you can use what they call an M-SATA drive, which is basically, how to describe it, a rather over large and thick SD card. It's about that long by about that, and about that thick. But it actually fits underneath the PCB, so you actually have a very small footprint, and you want to put it in some other sort of box. And we've got 32 gigabyte or 128 gigabyte of M-SATA drives. One thing, there is a slight issue that under certain circumstances, and it's actually a bug basically in the chip on the board. Sometimes some SATA devices aren't necessarily recognised. Now we found with the 2.5-inch SSD drives that we're using, we've now found sort of about only once in 100 does it fail to be detected. And it comes up, just not understood. Well, not understood, just because not being. So I've forgotten the exact phraseology, but basically it says just not found or something like that. Retry, whatever, and with a retry, it normally all works. On the M-SATA ones, at the moment the 128 gigabyte M-SATA for some reason tends to fail about 50% of the time, unfortunately. But so we're looking for one that is more reliably detected. But you know, if you just retry, once it's found, everything works. It's just the initial setting up of the device to say, I want to communicate with you at SATA 2 speeds. Please do that. Once that's done, you know, we've had 100% reliability. But it's just the turning on thing. Anyway, coming to the end of my time, I believe. So sorry if I've overrun, Matthew. Sorry, because he's ready and waiting. But first off, if I've got, if anyone hasn't got a set of prices, our prices, we've got basically a red one, a pink one for Raspberry Pi related stuff, a white one for the Rapido things, and green ones for our general prices. But whilst Matthew's setting up, please do come and whilst you're doing that, if anyone's got any questions, I will be in a moment going back to them to say doing a demonstration showing about the dual monitor aspect on the titanium and the iGet. But thank you.
It'll take me a couple of minutes to
But if anyone's got any questions whilst Matthew's setting up. Hi, Chris.
How comes Photodesk coming along for the...
Photodesk, right. One thing, yes, actually, that's... well, two aspects of that. Both systems rely on using what they call LT-RGB modes. Because basically the order of the red, green, blue is different. Now, on the Ionics, they're able to sort that one out by, on the early graphics cards, having a link or a solder bridge. On later systems, they manage to do it on the card, but on these it doesn't. So there can be issues with things not coming up with the right colours. Photodesk being one of them. Unfortunately, the chap who took over Photodesk maintenance has not had time to put effort into that at the moment, but I'm hoping that situation will change soon, or we are looking at alternatives to try and see if we can get someone else to maybe do it. There are some interesting problems there, but we are working on that to try and do that. But the LTRGB mode also affects things like NetSurf, but basically in NetSurf, if you tell it to use, I think it's one of the configuration options. It says to get around it, it basically, I think it's use OS colours or something. I've forgotten exactly, but that gets that working. Artworks, there was an issue, but Martin had a fix for that at the Southwest show. And that is available now. But some other programs, like in actual fact, the first version of RISC had a slight issue, and with that, but with a bit of information, Matthew was able to modify it so it does do all the colours correctly now. But so, any other questions?
Chris, you said the titanium board has flash RAM.
You said the titanium board has flash RAM,
Yes.
but it also has an SD card.
Well, in fact, both boards have flash RAM and SD slot.
Is it possible to put RISC in the flash RAM and Linux in the SD card slot, and then swap between them?
Right. On the titanium. So I'll just move my stuff out of Matthew's way.
Because I'm ready to start.
Oh, right. So last question then. Oh yeah, last question answer then. Right, on the titanium, they've just announced a way of actually, you boot into RISC and you can then go into Linux from RISC. You can't go back from Linux to RISC. On the iGet board, now that's a very interesting question, because you can tell it, if you tell it, the way to tell it to boot from SD card or boot from eMMC is one dip switch. So, I don't know how well you could solder a wire to bring that to the outside world. I've not even thought of that before, but it is actually, that is theoretically possible.
I've been soldering for over 50 years.
Now the question then is looking at your drive and formats, which is another thing that would be interesting to work out how you actually sort out your default drive.
Can't both RISC and Linux view FAT formatted drive?
The thing is, because the way when you use like on Raspberry Pi, this dual format overlapping, because so effectively, if you can say, well, okay, we'll have of your 250 gig, we'll have the FAT partition being half of that, and the rest of it RISC-OS. Only thing is, at the moment, system disk I think doesn't let you go more than about 300 meg or something, but there are some possibilities there. To do that. Yes, interesting. That is something to be developed. That I think. Sorry. Yes. Sorry.